Have you ever wondered, what if our home, our galaxy, is far bigger than we ever imagined? For decades, we believed the Milky Way stretched about 100,000 light-years across. It was printed in every textbook, drawn in every classroom, the neat spiral we all grew up seeing. But, well, it turns out that might have been an illusion, because when the James Webb Space Telescope, Gaia, and a fleet of radio telescopes began to peer through the dust, through the haze, and into the hidden edges of our galaxy, they discovered something extraordinary. The Milky Way isn't 100,000 light-years wide. It's closer to 200,000. Twice as vast, twice as ancient, twice as full of stories written in light and shadow. You see, measuring our own galaxy is like trying to map New York while standing in the middle of Times Square. No matter where you look, you're surrounded by the glow. But James Webb, with its infrared eyes, could finally see through the fog. It revealed that the faint stars, the gas, even the dark matter halo that cradles the Milky Way, stretch far beyond where we once drew its edge. And, that changes everything. It changes how we see our place in the cosmos, how galaxies form, how gravity shapes them. It even changes the timeline of our coming dance with Andromeda, the great spiral on a slow, inevitable collision course with us. What we thought was distant is already beginning. Perhaps, well, as Brian Cox once said, the universe isn't getting stranger. It's simply telling us more truth about itself. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. And, I'd love to hear from you. Where are you listening from tonight? It's always fascinating to see who's joining us from all around the world. So let's continue. It always begins with silence. The kind of silence that stretches farther than any sound, farther than light itself. In that vast stillness, the Milky Way spins, unaware of its watchers, unaware of how small and fragile our understanding really is. And, maybe that's the humbling part. For centuries we thought we knew our place here. We thought our galaxy was a quiet, orderly disk of stars, measured, mapped, and, well, mostly known. But the truth is that the more we look, the more it expands. The Milky Way isn't what we imagined. It's wider, older, deeper. It's not a neat spiral painted across the sky. It's a living, breathing ocean of suns, stretching beyond the reach of what we once called everything. And, there's something strangely intimate about realizing that. We stare at the night sky, and we see patterns. We see constellations. We see stories. But the stars don't know our names. They don't even know we're here. And yet, we keep mapping them. We keep trying to understand their distances, their motions, their hidden geometry. It's not just curiosity, it's longing. The kind of longing that sits deep in the bones of every human who's ever looked up and wondered if the darkness was really empty. Well, the latest findings from those vast radio surveys, the ones that sweep the galactic plane like slow, patient brushes of light, they changed everything. The Milky Way, we found, isn't 100,000 light-years across as textbooks once claimed. It's closer to 200,000, maybe more. That means the map of our home is wrong. The borders we drew around our existence, they've dissolved. We live inside something twice as immense as we believed. And, it's not just a number, it's a revelation. Because when the frame of your world suddenly doubles, your place inside it, your meaning, must shift too. The outer arms, those faint ribbons of gas and dust that no one noticed before, they tell a story of collision and survival. Long ago, smaller galaxies brushed against us, leaving behind trails of stars that still orbit in slow arcs. The Milky Way isn't a single pristine creation. It's a mosaic, a survivor of cosmic mergers and ancient chaos. And when we finally saw that, when the data whispered that the galaxy's edges weren't empty but alive, it felt like hearing the heartbeat of something vast and familiar for the first time. So what does that mean for us? Really, if our home galaxy is this enormous, this restless, this full of hidden structure, then our small solar system is, well, it's almost nothing. Not a center, not even a significant speck. And, yet we keep reaching outward as if we belong there. Maybe that's what defines us. Not scale, but hunger. We measure ourselves against infinity, not to feel small, but to feel part of it. The new maps built from hydrogen line data show arcs upon arcs, stellar streams looping through the dark like forgotten paths. And, well, it's strange, isn't it? We used to think the Milky Way was a single grand spiral, symmetrical and elegant. Now we know it's warped, twisted, bending under invisible forces, shaped by collisions with ghost galaxies. It's not order, it's memory. The galaxy remembers every encounter, every impact, every slow pull of gravity that sculpted its body. And when we look at it now, we're seeing scars, beautiful scars, stretched across 100 billion suns. Well, and somewhere in one of those faint, far-flung arms, a small blue planet spins, barely aware that it's part of anything greater. Earth's orbit, its delicate balance, feels so steady, so safe, but it's an illusion of perspective. From the galaxy's edge, our world is a single grain caught in a storm. And, still, from that grain came beings who built telescopes, who built dreams. It's not just improbable, it's poetic. We have this strange paradox. The more precisely we measure the universe, the more uncertain our place becomes. The discovery that the Milky Way's true size exceeds what we thought isn't just an adjustment to a chart. It's a philosophical event. It tells us that even our most fundamental truths are temporary. What we call knowledge is, only the current state of our ignorance, polished and named. And each new observation doesn't close a mystery. It opens another. Imagine it for a moment. Somewhere, beyond the faint rim where stars fade into the intergalactic dark, the Milky Way's outskirts still shimmer. Hydrogen atoms drift in long filaments, forming the faintest of bridges between us and the void beyond. Those borders aren't walls, they're invitations. And, maybe that's the essence of exploration. To keep walking toward what we can barely see, knowing it will change us when we arrive. So when astronomers recalculated the galactic mass, they didn't just revise numbers. They rewrote our relationship with existence. The arms we thought ended near Sagittarius now sweep far beyond, looping into regions no human eye has seen. The galaxy breathes larger now. It's not a fixed stage. It's a living motion, not a map, but a heartbeat. And we are pulses within it. Well, the thought that we've been living inside something so enormous without knowing, it feels both humbling and exhilarating, like standing in a cathedral with the lights off and realizing the walls stretch miles beyond where you thought they ended. The ceiling is higher. The echoes are deeper. You're smaller, yes, but also part of something far grander than you imagined. The galaxy, in that sense, is not distant. It's intimate. It's not out there. It's in here. And Well, every star we see tonight, every faint point in the dark, is part of that same structure. It's not chaos, it's pattern. But the pattern is so vast that our minds can only trace fragments of it. That's what science tries to do. Turn fragments into understanding. But even understanding feels like another kind of longing, doesn't it? Because once we know that there's more, we can't stop wanting to see it. What's most astonishing isn't just the scale, but the symmetry of the unknown. For every arm we've mapped, there are others veiled in dust. For every cluster we've counted, there are millions beyond reach. The more precise our instruments become, the more the galaxy recedes, as if it wants to remind us that discovery is never possession, that the closer we get, the more infinite it becomes. And, maybe that's the quiet lesson hidden in the data. The universe doesn't shrink to fit our understanding. Our understanding must stretch to meet it. The Milky Way isn't a thing we look at. It's a thing we live inside. We orbit its core without ever glimpsing it directly. We chase its structure through indirect light, through echoes, through inference. It's not knowledge by sight. It's knowledge by faith in the mathematics of motion and the constancy of light. Well, and there's something deeply human about that. To believe in what can't be seen, but can be known. That's what drove the first astronomers, and what still drives us now. Each measurement, each correction to our maps, is a step toward humility. We grow wiser not by mastering the universe, but by realizing how vast it truly is. The discovery of the Milky Way's greater size didn't come in a single burst of revelation. It came slowly, through decades of patient observation. Layers of data, corrected, remeasured, reimagined. It's not heroism, it's persistence. Science, like the galaxy itself, builds through time, not miracles. And, when you think about it, that persistence mirrors our own evolution. From cave paintings of stars to orbital telescopes peering through dust, we've always been reaching toward the same horizon. And as the Webb telescope joins the chorus of instruments mapping the heavens, our picture of the galaxy sharpens again. We see deeper into the dust lanes, we measure more precisely the light of ancient stars, and we begin to sense the rhythm of the spiral itself. The Milky Way moves, it sways, it ripples. It's not static. It's alive with gravitational waves and stellar tides. The universe doesn't just exist, it dances. And, in that dance, we glimpse something timeless. It's not just about stars and gas, it's about belonging. The realization that we come from this, that we are made of this, that the calcium in our bones was once starlight, that the universe writes itself through us. It's not poetry, it's physics. But physics, when you look closely enough, becomes indistinguishable from awe. Well, maybe that's what this first chapter of discovery means. To stand on a small planet and realize the stage is larger than we thought, the story older, the cast endless. We thought the Milky Way was a boundary. It's not. It's a beginning. The map doesn't end at the edges of our instruments. It begins there. And as we turn our eyes outward, past the last known spiral arm, we start to feel the pull of what lies beyond. Not just other galaxies, but other ways of seeing, other ways of being. So when we talk about the Milky Way now, we're not talking about distance, we're talking about perspective. The measure of space has become the measure of wonder. And in that expansion, something inside us expands too. We start to understand that the universe doesn't grow. It's our vision that unfolds, layer by layer, toward truth. And somewhere, beyond that truth, another mystery waits, calling softly, endlessly, toward the next horizon of light. When the first streams of data arrived from Gaia, it didn't look like much, just, dots. Endless dots of numbers and coordinates, a billion small lights reduced to data. But buried inside that ocean of precision was something transformative. Each dot, each star, was not just a point in space, it was motion. For the first time, we weren't looking at the sky as a flat painting. We were, seeing it breathe. Gaia, orbiting the sun from its calm position near Lagrange point 2, traced the subtle wobbles of stars, their tiny sidesteps through the years. And from that dance, it mapped the skeleton of our galaxy. Well, it's hard to express what that means. Before Gaia, our maps of the Milky Way were, in a way, sketches. Beautiful, but incomplete, drawn from within the fog. Now, for the first time, we could step back, metaphorically, and watch the motion itself. We could see how stars moved in flocks, in patterns, in spirals, pulled by invisible currents of gravity. It was like standing in a dark forest for centuries, seeing only trunks and shadows, and then suddenly realizing that the forest is alive with wind, with hidden paths, with unseen depth. And, the precision. My God, the precision. Gaia measured the motion of over 1 billion stars with accuracy fine enough to detect a hair's width at thousands of kilometers away. That kind of clarity doesn't just reveal, it rearranges. When the data was combined with other observations, the familiar picture of the Milky Way began to twist, to stretch, to expand beyond anything the old charts had dared to imagine. But Gaia alone wasn't enough. Its eyes, though sharp, could not pierce the dust. There are places, vast lanes of interstellar smoke and shadow, where visible light simply cannot go. The very heart of the galaxy, the dense arms where newborn stars still burn behind clouds of carbon and silicate, were still a mystery. And that's where James Webb stepped in. The Webb telescope, stationed far beyond the moon, didn't need visible light. It saw in infrared, the language of heat, of hidden fire. It could look straight through the dust that had blinded us for millennia. Well, and when Webb's first images of the galactic plane came back, they didn't just fill gaps. They changed the shape of the story. Those faint, forgotten regions, those dim outskirts we once thought were empty, suddenly glowed. There were stars there, clusters, filaments, faint arcs of light reaching farther than our models predicted. The Milky Way didn't end where we thought it did. It went on, whispering into the dark, twice as wide, twice as old in memory. And, it wasn't just about the stars Webb could see. It was about what it could infer. Using the infrared glow of star-forming regions, astronomers realized that entire stellar nurseries existed far beyond the old galactic boundaries. There were clouds of hydrogen out there, stretched thin but alive, forming faint generations of stars in the cold. The galaxy, it turned out, wasn't a finished structure. It was still building itself, still expanding its reach into the void. The radio telescopes confirmed it. From the plains of Australia to the deserts of Chile, arrays of dishes listened for the faint 21-centimeter line of neutral hydrogen, the universal whisper of matter itself. That sound, that ancient radio frequency, mapped what our eyes could not. And when Gaia's precise stellar motions, Webb's deep infrared vision, and the radio telescope's hydrogen maps were laid atop one another, a single truth emerged. The Milky Way was not 100,000 light-years across. It was more than 200,000. It didn't just grow in our imagination. It revealed its true self. That moment was like pulling away a curtain that had hung for generations. Scientists stared at their screens in disbelief. Decades of models, beautiful, elegant, wrong, had to be rewritten. The outer arms, once thought to fade into nothing, curved gracefully into new territories of light. The galaxy's spiral wasn't four-armed. It was complex, irregular, rich with distortions caused by ancient collisions. And, perhaps that's the quiet wonder of it. Every time we believe we've seen the whole picture, the universe gives us more. It's not deceptive. It's just infinite. Gaia taught us to measure motion. Webb taught us to see through shadow. Radio telescopes taught us to listen to silence. Together, they turned the Milky Way from a static diagram into a living organism. Well, and it's not just the scale that matters. It's the implication. If the Milky Way is larger, then its mass is larger. Its gravity reaches farther. Its influence, its presence in the cosmic web, is stronger than we thought. The gravitational field that holds the Magellanic Clouds, that shapes the orbits of satellite galaxies, now extends deeper into space. The Milky Way is not a simple spiral. It's a vast gravitational ecosystem. And, well, when the numbers settled, when the simulations began to align with observation, it became clear that we had been looking at a cropped version of reality. For all our instruments, for all our cleverness, we had only been seeing what light allowed us to see. But the universe doesn't reveal itself in visible light. It reveals itself in patterns of motion, in the gentle radio hum of hydrogen, in the faint warmth of distant dust. There's something poetic in that, isn't there? The truth hides in the wavelengths our eyes can't perceive, but our minds can. That the deeper we look, the more we realize that seeing isn't the same as knowing. It's not just about light, it's about connection. Each new instrument, Gaia, Webb, the radio arrays, became an extension of our senses, like evolving new organs to perceive the cosmos. The collaboration between these observatories marked a turning point in how humanity studies its home. It wasn't a single discovery. It was a symphony of data. Gaia mapped the movement. Webb mapped the invisible. The radio telescopes mapped the breadth of the galaxy itself. And when those melodies overlapped, the harmony revealed the true vastness of where we live. And, what's striking is that this wasn't just a scientific victory. It was a human one. Thousands of people, from engineers designing cryogenic mirrors to programmers handling petabytes of raw information, worked in quiet synchronization. They didn't just build machines, they built a bridge across darkness. Every pixel, every line of data, carried decades of human patience, of faith that light, no matter how faint, always finds a way through. Well, and yet, when the findings were announced, there was that pause, that silence that comes before the applause. Because it's not easy to grasp what twice as large really means. Numbers can feel cold, but this discovery wasn't. It was warm, humbling, intimate. It meant that our cosmic home had been holding more than we ever realized. More stars, more dust, more hidden beauty. It meant that the night sky, even in its familiar form, had always been deeper than our imaginations. The shift in scale rippled through astronomy like a quiet wave. Every model of galactic evolution, every simulation of cosmic structure had to adjust. Distances between galaxies, gravitational boundaries, even the expected timing of collisions, all had to be recalculated. The Milky Way wasn't just bigger, it was denser, more massive, more entangled in the web of the universe. And, That recalibration changed how we see our neighbors too. If our galaxy was underestimated, what about Andromeda? What about Triangulum? What about the billions of other spirals scattered across the void? Maybe, just maybe, all of them were larger than we thought. Gaia's reach would eventually extend to them. Webb's eyes would peer into their hearts, and our understanding of scale itself would shift again. So in that sense, the discovery wasn't an ending. It was a threshold. The instruments we built to look outward turned inward, revealing the limits of our own assumptions. It's not that the galaxy grew, it's that we finally saw it whole, and that realization feels, somehow, alive. The galaxy hasn't changed, our perception has, and that's the subtle miracle of science. The universe stays still while we evolve to meet it. And, as 2025 unfolds, these observatories continue their patient watch. Gaia's data stream keeps refining star paths. Webb peers deeper into the hidden arms. Radio arrays listen more carefully to the hydrogen song. Each discovery builds upon the last, like stones in an invisible cathedral of knowledge. The Milky Way is no longer a fixed map. It's a moving story, told across wavelengths, stitched together by minds scattered across Earth. Well, and that story, still unfinished, now beckons us toward something even stranger. Because as we learned to trace the visible edges of our galaxy, we also began to notice patterns, streams of stars that move like rivers across the dark, remnants of ancient collisions flowing beyond the known arms. They are threads, faint but unbroken, leading us toward the next revelation, the next chapter of this galactic story, where the stars themselves begin to remember what shaped them. The first time we noticed them, those faint lines in the sky, we didn't even realize what they were. They looked like noise, like cracks in the data, like imperfections in a perfect picture. And, yet they kept appearing, thin trails of stars stretching across the night in strange, graceful arcs. They weren't random. They weren't chance. They were, memory. Stellar streams, the soft handwriting of gravity itself. Each one marked the path of something that once was whole, a small galaxy or cluster that the Milky Way had pulled apart, star by star, until only the trail remained. That was the first time we saw the galaxy not as a structure of symmetry and order, but as something that grows by consuming, something that remembers through its scars. Well, it's not an easy thing to picture. A river made of stars, flowing across millions of light years. But that's what these streams are. They move, not like light, not like wind, but like time, slow and unstoppable. The Sagittarius stream, the GD1 stream, the Helmi streams, each one loops around the galaxy in quiet defiance of its borders. And that's what caught our attention. These stellar rivers didn't stop at the edges we had drawn. They stretched beyond. They told us that gravity's reach, the Milky Way's invisible skeleton, extended farther than we had ever thought. When Gaia's data came in, showing the proper motion of 1 billion stars, it was like lifting the lid on a cosmic time-lapse. Suddenly, we could see these streams move, could see their shape against the backdrop of the galaxy. They weren't faint anymore. They were alive. The galaxy was no longer a static disk. It was a dynamic, swirling organism, pulling, devouring, weaving. The streams revealed how the Milky Way became what it is, not through creation, but through consumption. Smaller galaxies, long gone now, were absorbed and stretched into ribbons of light, feeding the growing spiral. And, there's something haunting in that, isn't there? The idea that beauty and destruction are, the same process viewed from different scales. The streams are fossils, but they move. They are ruins, but they glow. That's the paradox of the Milky Way. It builds itself by unbuilding others. It's not a fixed monument, it's an act in motion. And when you realize that, when you see that the stars you're studying were once part of other galaxies, you begin to sense just how porous the universe really is. There are no real borders, only tides. Well, astronomers began to trace these streams with increasing precision, mapping their curves, their densities, their speeds. What they found was astonishing. Some of them extended tens of thousands of light years beyond the galactic plane, far into regions we once called empty space. But if stars were there, then gravity was there too. The invisible halo of dark matter, the unseen framework that holds everything together, must stretch that far. The streams, in their elegance, were testifying to something vast and invisible. And, that's how the galaxy began to show its true shape, not through light, but through motion. Light fades, but motion persists. The way a stream curves tells you where the gravitational field bends. The way its stars scatter tells you how deep that gravity runs. So we began to use them as probes, like needles testing the fabric of the dark. The Milky Way, once just a glowing disk, now appeared as an enormous, layered structure. A bright center surrounded by faint, graceful arcs of stellar debris. And those arcs whispered that our galaxy's influence extends far beyond the bright spiral arms, perhaps even farther than 200,000 light years. The Sagittarius stream is maybe the most famous of them all. It's the torn remains of a dwarf galaxy that ventured too close. For billions of years, it orbited the Milky Way, and each pass stripped more of its stars away. Now, its remnants loop around us in great glowing ribbons, one above the galactic plane, one below. From Earth, it's almost invisible to the naked eye, but in infrared and radio, it dominates. It's a reminder that galaxies are not still. They are tidal, pulling and reshaping each other across cosmic time. And, well, that realization changed how we think about our home. It's not just that we live in a galaxy, it's that we live inside a process, a constant gravitational negotiation between past and present. The Milky Way is, in a way, a cannibal. An elegant one, yes, but still a cannibal. And every stream we find tells another story of what it has consumed. Each is a ghost, and together they form a skeleton, the unseen structure of the galaxy revealed through the faintest whispers of motion. Well, what Gaia and other observatories showed is that there are dozens of these streams, maybe hundreds, wrapping around the Milky Way like rings of memory. Some come from globular clusters, others from full dwarf galaxies. And as we follow their paths, we can reconstruct the timeline of our galaxy's growth. The Milky Way didn't form all at once. It grew like a coral reef, layer by layer, collision by collision. It's not, a single birth. It's a story of accretion, of survival. The physics of it is breathtaking. Imagine a smaller galaxy, maybe a few billion stars, drifting through the cosmic web. It moves toward the Milky Way, caught by the larger galaxy's gravity. At first, it orbits peacefully, but with each pass, the tidal forces stretch it thinner. Stars begin to drift away, pulled into long tails. Over billions of years, the smaller galaxy dissolves, leaving behind only the stream. That's how the Milky Way feeds. That's how it grows. Not in bursts, but in tides. And, that's the beauty of these discoveries. They turn destruction into knowledge. By following the streams, astronomers can measure the gravitational potential of the Milky Way, the invisible curve of its power. Each stream bends differently, revealing the underlying distribution of dark matter. The more streams we trace, the clearer that skeleton becomes. It's like feeling the bones beneath the skin of something immense. Some of these streams are so faint that they can only be detected statistically. Tiny overdensities of stars moving in the same direction. Others, like the Orphan Stream or GD1, are almost elegant, clean arcs that tell of ancient, precise dances. And when we model them, when we compare their orbits to simulations, something fascinating appears. The Milky Way's halo isn't smooth. It's clumpy, irregular, rippled. That suggests that our galaxy has been disturbed, nudged, pulled, shaped by collisions that left echoes in its outer halo. Even now, the Milky Way is not settled. It's trembling with the memory of what it's eaten. Well, and it's humbling to realize that we can read this history like archaeologists, sifting through celestial ruins. The data from Gaia gives us positions, motions, distances. The models give us age. We can reconstruct the last 10 billion years of our galaxy's story from these stellar rivers. And what that story tells us is not of peace, but of persistence. Galaxies don't age quietly. They survive. And, there's something deeply human in that recognition. We, too, are built from what came before, from fragments of older things. The Milky Way, in its silent growth, mirrors our own history, a collection of inheritances, of absorbed memories. It's not just physics, it's poetry written in gravity. One of the most extraordinary realizations came when astronomers noticed that some streams seem to align with dark matter simulations. Their curvature, their distribution, their speed, all matched what would happen if an invisible halo surrounded the galaxy, extending far beyond the stars. So, in a sense, these streams became proof of the unseen. They showed where dark matter must be, not through detection, but through consequence. You can't see the wind, but you can see the trees move. The stars, in that sense, are our trees. And, well, as we map more of them, a pattern emerges. The Milky Way's outer halo isn't just wider, it's alive with motion, full of these faint remnants that never truly disappear. They orbit for billions of years, slowly fading but never gone. And somewhere among them, perhaps, are the traces of galaxies we've never even named. Ancient wanderers consumed long before humans learned to look up. Well, and it's in this motion, this quiet ballet of debris, that we begin to sense the true scale of the galaxy's gravity. It doesn't end where the light fades. It continues, reaching outward, holding these faint streams in its embrace. The Milky Way's influence extends like a slow heartbeat into the void. And that changes everything. Because it means our galaxy isn't a flat disk. It's a vast, three-dimensional ocean of motion and memory. And when you look at it that way, you start to understand that we're not fixed inside the galaxy. We're part of its flow. Our sun, our solar system, even our tiny orbit, moves within this grand current, circling the galactic center every 200 million years. We are, in every sense, adrift. Not lost, but carried. And, maybe that's why these discoveries matter so much. They remind us that the galaxy isn't a thing we look at. It's a thing we're inside of, a living system that holds our history and our future. Each stream, each faint line of stars, is both a record and a revelation. They tell us that the Milky Way's size is not defined by light, but by gravity, by the reach of its pull. Well, and now, as 2025 unfolds, new surveys are finding even fainter structures, streams that cross each other like filaments in a vast web. It's beginning to look as if the galaxy isn't just surrounded by these streams, it's made of them. They are the skeleton, the veins, the architecture of its being. The stars within them are the last words of long-forgotten galaxies, still speaking across time. And, somewhere beyond those streams, where the faintest ones dissolve into the dark, another question begins to form. If gravity's reach is so wide, if the Milky Way's skeleton extends farther than we thought, then what invisible structure gives it shape? What unseen hand molds the form we see? That question leads us forward, toward the next mystery, the dark matter that frames it all, the unseen architecture that holds even these rivers of light in place, waiting, silent, for us to notice. It begins, where the light ends. Out beyond the stellar streams, past the faintest traces of hydrogen and the last visible stars, the Milky Way keeps going. But not in light, not in dust, not in anything we can see. What holds it together there is something else, something silent. Astronomers call it dark matter, but that name, says less than it explains. It's not darkness, it's structure. It's not emptiness, it's the invisible skeleton of everything we know. And that's where the real story begins, in the unseen. Well, we first realized something was missing nearly a century ago. The stars at the edges of galaxies were moving too fast. According to Newton's laws, they should have flown away, spinning out into the void like sparks from a wheel. But they didn't. They held their course, orbiting far beyond where gravity should reach. Something unseen, was holding them in place. At first, it was dismissed as measurement error, a trick of instruments. But decade after decade, the pattern persisted. It wasn't the stars that were wrong. It was our picture of what a galaxy is. And, when the Milky Way was remeasured, when its size doubled under the eyes of Gaia and Webb, that mystery grew even deeper. Because the larger our galaxy became, the more obvious it was that light alone couldn't explain its gravity. The visible stars, the glowing gas, even the hidden dust, they all added up to only a small fraction of the mass required to keep everything bound. The rest, about 90%, is invisible. The Milky Way is not a structure of stars. It's a shadow held in place by something we cannot see. Think of it like this. If the bright spiral arms are windows, then dark matter is the frame. The steel skeleton hidden behind the glass, giving shape to what we see, but never itself seen. Without it, the windows would collapse, the arms would unwind, the galaxy would dissolve. It's not just important, it's essential. It's what makes existence possible on this scale. Well, and yet, for all its importance, dark matter remains one of the most elusive ideas in science. We can't touch it, can't trap it, can't make it shine. We know it's there only because of how it pulls. It bends starlight, curves orbits, sculpts galaxies. It doesn't interact with light. It only interacts with gravity. And, maybe that's what makes it so haunting. We're surrounded by it, immersed in it, but we'll never see it directly. It's not out there. It's in here, all around, flowing through us like an invisible tide. The best estimates suggest that for every gram of normal matter, atoms, molecules, everything that burns or breathes, there are 5 grams of dark matter. 5 times more of the universe is unseen than seen, and that realization changes everything. When Gaia traced the motions of stars across the sky, astronomers used those movements to map the gravitational field, and the field didn't match the light. The galaxy's mass extended farther, wrapped in an enormous halo of invisible matter stretching hundreds of thousands of light-years beyond the luminous disk. It was as though the Milky Way lived inside a bubble of shadow, a ghostly cocoon that shaped everything from the rotation of its stars to the paths of its satellites. And, well, that halo isn't uniform. It's not smooth or simple. Simulations show it's clumpy, rippled, marked with the fingerprints of collisions long past. The dark matter, though invisible, remembers. Each small galaxy that fell into the Milky Way left ripples in that invisible sea, waves of gravity still rolling through the present. Those waves, in turn, tug on the visible stars, creating the subtle warps and oscillations we now see in the disk. So the light we see is the echo of the dark we can't. The Milky Way's visible shape is just the surface pattern of something deeper. And the irony is, we discovered all this by accident. We weren't looking for darkness, we were measuring light. But in those measurements, in the way stars refused to obey the math of visible matter, we stumbled onto the unseen majority of the cosmos. It's not that dark matter appeared, it's that we finally noticed its absence. That's how science often works. It's not about finding new things, but realizing what's been missing all along. Well, some scientists like to imagine dark matter as a vast, invisible lattice surrounding galaxies, a kind of cosmic scaffolding. Galaxies don't form first and attract dark matter. It's the other way around. The dark matter comes first, condensing under gravity into enormous halos, and the gas and stars gather inside those wells. We are, in a sense, living inside a gravitational nest that existed long before our stars were born. Without dark matter, there would be no Milky Way, no sun, no Earth. It's not decoration, it's foundation, and, there's something profoundly humbling about that. The atoms that make up everything familiar, carbon, oxygen, iron, are the exception, not the rule. The universe is mostly made of what we cannot touch. It's not that we are missing a small piece. It's that we are the small piece. We live in the bright embroidery of something much larger and darker. But what exactly is dark matter? That's still, well, one of the great unanswered questions. We have theories, of course, particles that barely interact, perhaps some ancient form of matter left over from the first moments after the Big Bang. They could be WIMPs or axions, or some unknown field we haven't imagined yet. But none of them have shown themselves. The detectors buried deep underground, shielded from cosmic rays, wait in silence. The instruments on satellites measure cosmic radiation, hoping for clues. But the darkness stays quiet. It's patient. It's persistent. It hides perfectly in plain sight. And, well, maybe that's what frustrates and fascinates scientists most. It's not that dark matter refuses to reveal itself. It's that it has no reason to. It's doing exactly what it's meant to do. It holds, it shapes, it binds. Its silence is stability. If it spoke, the galaxy would fall apart. Well, and every time we think we're getting closer, it seems to move just out of reach. We build better detectors, colder instruments, more sensitive telescopes. And yet, still, nothing. But that doesn't mean failure. It means we're learning how to listen better. Maybe, the discovery will come not from direct detection, but from its fingerprints elsewhere. from the way galaxies rotate, from the lensing of distant light, from the subtle tremors in the cosmic microwave background. The truth often hides in the edges of what we already know. And if dark matter gives the galaxy its structure, then dark energy, well, that's another mystery entirely, one that pushes instead of pulls. But before that, there's still more to learn here, in this invisible architecture we call home. Because if the Milky Way's halo is truly this massive, this far-reaching, then it doesn't just define the galaxy's shape, it defines its destiny. The future collision with Andromeda, the orbits of its satellite galaxies, even the stability of our sun's path, all depend on the invisible gravity of dark matter. And, simulations show that as the Milky Way and Andromeda draw closer, it won't be their stars that meet first. It will be their halos. The invisible will touch before the visible does. The first collision will happen in darkness. That idea still gives me chills. The thought that before we ever see the two galaxies merge, their unseen skeletons will already be intertwining. It's not just poetic, it's physical truth. The dance begins in shadow. And perhaps that's what the universe has been trying to tell us all along, that what we don't see is what matters most. Light dazzles, but gravity endures. We built our understanding of the cosmos from photons, but the deeper structure comes from the invisible web beneath them. The stars are ornaments on a frame of darkness. Without that frame, there would be nothing to hold the light. Well, and as 2025 continues, new data from gravitational lensing surveys and radio mapping are starting to outline the dark matter halo of our galaxy in greater detail than ever. We can see its distortions, its asymmetries, its ripples. It's not static, it's alive, shifting, responding to the pull of nearby galaxies. And the more we map it, the more it resembles something organic, a nervous system of the cosmos, invisible, but vital. And, well, I sometimes wonder what it means for us, philosophically. If the majority of the universe is invisible, then what does it say about perception itself? Maybe, what we see isn't reality. It's the surface of reality. The real universe is the one we can't perceive, the one that holds everything else together. It's not a void. It's presence in disguise. And if that's true, then knowledge itself becomes a kind of shadow play, an endless attempt to infer the shape of what cannot be seen. The more we look into the dark, the more we realize that it's not an absence. It's a different kind of fullness. And maybe that's why, despite its mystery, dark matter feels strangely comforting. It means we are surrounded, held, connected by something larger than comprehension. It's not hostility, it's structure. It's not emptiness, it's the quiet hand that keeps the stars from flying apart. And as we begin to trace that hand, to model its reach, to sense its quiet rhythm, another realization starts to take form. If this invisible framework defines the galaxy's shape and weight, then perhaps we've underestimated everything: its mass, its reach, even its future. The Milky Way's true gravitational pull may extend much farther than we thought, changing not just how we see the present, but how we predict what comes next. And that realization leads naturally, inevitably, to the next question. How heavy is our home really? How much does the invisible weigh? It turns out, that the Milky Way weighs more than we ever imagined. Not a little more, not by a margin of curiosity, but by a scale that, redefines our sense of proportion. For decades, we believed its mass hovered around 1.5 trillion suns, a comfortable, comprehensible number. But now, With the convergence of data from Gaia, James Webb, and radio telescopes, that certainty dissolves. The numbers rise, quietly but steadily, until they rest somewhere near 4 trillion solar masses. That's not just an adjustment, it's a revelation. It means our galaxy is 3 times heavier than we thought. Well, and it's not that the Milky Way gained weight overnight, it's that we finally learned to see the invisible. So much of that mass is hidden, in the vast halo of dark matter, in the diffuse gases that glow too faintly for our eyes, in the ghostly outskirts where light gives way to silence. We weren't wrong before. We were incomplete. The galaxy was always this massive. We just didn't know how much of it had been missing from our view. And, when you start to think about 4 trillion suns, it almost stops meaning anything. Numbers that large slip through language. It's not about counting, it's about gravity. Because mass isn't just weight, it's power. It's the pull that keeps everything bound together. The Milky Way's true mass means its gravitational field stretches farther. Its influence reaches deeper into space. The halo of gravity that surrounds us doesn't end where the light ends. It continues, wrapping the galaxy in an unseen hand. Imagine standing inside a vast cathedral whose walls you can't see, whose roof stretches beyond the stars. You think you know its boundaries, but every time you look, the shadows recede, revealing more of the structure you live within. That's what this discovery feels like. The Milky Way isn't a flat spiral painted against the night. It's an ocean of mass, an empire of invisible pull. The stars are just the surface glitter. The real body lies beneath. Well, and this matters because mass changes everything. The orbits of stars, the dance of satellite galaxies, even the distant relationship between the Milky Way and Andromeda, all must be recalculated. The more massive the galaxy, the stronger its gravitational influence and the wider its dominion. Dozens of small satellite galaxies, tiny companions drifting in the galactic outskirts, may not be as distant as we thought. They may be, more tightly bound, more deeply caught in the Milky Way's gravity than models once predicted. The cosmic hierarchy shifts. What we thought were neighbors might actually be parts of the same family. The Magellanic Clouds, those soft smudges in the southern sky, could be moving within the Milky Way's extended halo, not merely orbiting beyond it. Their paths, their speeds, even their histories, all must be rewritten. And, well, when scientists first recalculated the Milky Way's mass, they were skeptical. The idea that we had underestimated our own galaxy by a factor of 3 sounded absurd. But as more evidence came in, from the motions of distant globular clusters, from the velocity of stellar streams, from the distribution of dark matter, the conclusion became unavoidable. The Milky Way is enormous, heavier than nearly all galaxies in its class, rivaling even Andromeda in weight. The two, it turns out, are not unequal partners approaching each other. They are twin giants, bound in a slow gravitational embrace. And if mass defines motion, then this discovery also redefines time. The heavier the Milky Way, the sooner its collision with Andromeda will occur. Our galactic future, once placed billions of years away, now draws a little closer. The two halos, vast clouds of dark matter, are already brushing, exchanging gravity long before any stars will meet. The first contact, has already begun, quietly, invisibly. Well, and it's astonishing to think how this knowledge comes not from direct observation, but from inference, from the way stars move, from the curves of their paths. We don't weigh the galaxy by scale. we weigh it by motion. Every star is a clue, every orbit a whisper of gravity. When astronomers trace those motions with Gaia's precision, they can see how deeply each star feels the pull of the Milky Way's mass. The faster the outer stars orbit, the stronger the unseen gravity must be. And the stronger that pull, the greater the hidden weight. And, when those numbers came together, when the models finally converged on 4 trillion solar masses, it was like realizing that your home stands on an entire continent when you thought it was an island. The Milky Way is not a local neighborhood. It's a gravitational city sprawling beyond imagination. The deeper implication of this discovery is scale. If our galaxy is heavier than believed, then its gravitational reach extends farther, altering our understanding of the locals, group, the small cluster of galaxies we inhabit. The Milky Way's influence overlaps more strongly with that of Andromeda. Their halos merge before their stars do. In cosmic terms, that's already a meeting, a slow and silent handshake in the dark. And yet, despite its mass, the Milky Way moves gracefully. Its arms still spiral with delicate balance. Its stars still glide in rhythm. That's the beauty of it. Immense power held in harmony. The galaxy carries 4 trillion suns worth of mass, yet from Earth it appears as a soft band of light, fragile as a breath. It's a reminder that scale doesn't define experience. The vast can still appear gentle. Well, scientists often talk about the mass budget of a galaxy, the accounting of all its matter, visible and invisible. Before Gaia and Webb, our budget was wrong. We thought we could see most of it. Now we know we were only looking at the surface layer, the bright crust floating atop a vast sea of unseen material. The dark matter halo alone accounts for most of the mass. But even within the visible galaxy, there are hidden reservoirs, diffuse gas, faint stars, ancient clusters drifting in the galactic outskirts. Each discovery adds another decimal, another realization that we had only begun to measure. And, that understanding ripples outward. If the Milky Way's mass has been underestimated, perhaps every galaxy we've measured has been too. The equations we use to weigh the universe might need rewriting. That's the danger and the beauty of discovery. Every time we measure more precisely, reality shifts beneath our feet. And this new number, 4 trillion solar masses, also changes how we see the Milky Way's role in the cosmic web. It means the galaxy sits deeper in the gravitational fabric, its filaments connecting more strongly to neighboring clusters. The invisible threads of dark matter that bind galaxies together are not abstract. They're structural. The Milky Way isn't drifting alone. It's anchored, stitched into the grand tapestry of the universe. Well, and the more massive the galaxy, the stronger its pull on its satellites, and the more satellites it should have. Observations now confirm this. Small galaxies, once overlooked as background noise, are appearing in droves. Tiny, dim, ancient galaxies orbit in the outskirts like embers around a fire. Some are so faint they can only be seen through the movement of their stars. They are relics of an older cosmic age, drawn in by the Milky Way's growing gravity. And, well, this discovery redefines the concept of belonging. We thought these dwarfs were separate, distant entities, but now we realize they've always been within our galactic family, bound by an invisible tether. The Milky Way's gravitational field doesn't end with the stars we can see. It extends deep into the dark, claiming the space between galaxies as part of its dominion. In that sense, mass becomes more than a measurement. It becomes identity. The galaxy's mass determines what it holds close and what it lets go. It decides which stars will remain and which will drift away. It defines the architecture of belonging. And that brings a strange comfort. To know that even at the cosmic scale, there are boundaries of connection, fields of gravity that hold, that keep. Well, and it also forces us to re-examine one of our most human illusions, that we stand apart from the cosmos. We weigh galaxies as if they were objects outside of us, but we are made of them. The same gravity that binds the stars binds us. When we speak of the Milky Way's mass, we're speaking quietly about the weight of our own existence. And, maybe that's why the discovery feels so personal. To realize that the galaxy is heavier is to realize that our home is more substantial than we thought, that there is more holding us, more connecting us than we ever imagined. The Milky Way doesn't just contain us, it sustains us. And as 2025 unfolds, new missions are refining these measurements. The Vera Rubin Observatory, preparing for its vast sky survey, will map the motion of countless faint stars in the galactic outskirts. Gaia's next data release will sharpen its precision even further. Each new observation adds weight to the truth. The Milky Way's true mass is monumental, not static, but alive, its gravity still shaping the space around it. Well, and yet, even this number, 4 trillion solar masses, is only an estimate. It could still grow. Every time we look deeper, the boundaries move outward. The unseen becomes measurable. The known becomes a prelude to the next unknown. And that's the rhythm of discovery. It doesn't stop at certainty. It expands from it. The galaxy we thought we understood is still becoming. Its mass, its structure, its reach. They're all evolving as our eyes sharpen. And beyond that, something even more compelling awaits. Because if the Milky Way's true weight changes the way we see our place, then what happens when 2 galaxies of this scale begin to move toward each other? What happens when mass meets mass? When gravity becomes collision? When the invisible scaffolding of dark matter begins to merge? And, that's where our journey turns next. To the slow, inevitable meeting between the Milky Way and Andromeda, not as a catastrophe, but as a dance, a merging of 2 immense, invisible architectures in the dark. It begins, with a slow pull, a tug so faint you can't feel it, but so constant that it changes everything. The Milky Way and Andromeda, 2 vast spirals drifting through the local group, are moving toward each other, not away. In a universe that expands, they are exceptions, 2 dancers moving upstream against the cosmic current. And, what makes it stranger still is that this isn't something that will happen. It's something that's already happening. The collision has begun, not in light, but in shadow. Well, when we say collision, we imagine chaos, stars smashing, planets burning, skies torn apart. But that's not what this will be. It's not destruction. It's a merging. It's not a crash. It's a slow, gravitational embrace stretching over billions of years. The galaxies will pass through each other like ghosts, their stars separated by such vast distances that they almost never collide. Gravity will do the work instead, reshaping, merging, rewriting their orbits until both dissolve into a new form, a single, elliptical galaxy that astronomers already call Milkomeda. And, well, that future isn't as far as it once seemed. The new measurements, the 4 trillion solar masses of the Milky Way, the comparable weight of Andromeda, have changed the clock. What we once thought would happen in 5 billion years may now come hundreds of millions of years sooner, Because, the heavier the galaxies, the stronger their pull. The more massive their halos of dark matter, the faster the approach. The first contact won't be visible in light. It will happen in darkness as the two invisible halos begin to overlap. Those halos, vast and ghostly, extend hundreds of thousands of light years beyond the visible stars. They are like two enormous transparent clouds, each filled with the gravitational memory of billions of years. Long before the bright disks touch, their dark matter will begin to mingle, exchanging energy, distorting shape. It's not that the galaxies move through empty space, it's that they move through each other's gravity. And, that's already happening. Even now, tiny satellites between them, the dwarf galaxies that orbit both, are being stretched, pulled by two masters. The universe, in that sense, is already choreographing their dance. Well, and it's not a dance of equals exactly. Andromeda is slightly larger, its central bulge brighter, its disk wider. But the Milky Way, as we've learned, is heavier than once thought, stronger, more deeply rooted in its halo. That balance makes the future collision more symmetrical than we imagined. It's not a devouring, it's a meeting of peers. Two spirals, each ancient, drawn by the invisible thread of gravity toward a shared destiny. And, the numbers are as beautiful as they are humbling. Andromeda approaches at about 110 kilometers per second, fast enough to cross the distance between the two galaxies, 2.5 million light-years, in about 4 billion years. But, the collision won't happen all at once. It will unfold in stages. First approach, first passage, recoil, and final merger. Each phase will last hundreds of millions of years. Each will reshape both galaxies more profoundly than any single event since their birth. The first approach will see their disks distort, tidal arms stretching across space like ribbons. Stars will be cast outward, flung into vast streams that will one day form the outer halos of the merged galaxy. Some systems, our sun among them, may drift outward, carried by these tides. The night sky, then, will change. Future observers on Earth, or whatever remains of it, will look up to see a double galaxy filling the heavens, two spirals entwined in slow motion. The Milky Way, as we know it, will no longer exist as a separate entity. But it won't vanish. It will transform. It's strange, isn't it? To think that our galaxy's end is not an explosion, but a union. That the same force that built it will someday merge it into something new. Gravity doesn't destroy. It reworks. It's patient. It's inevitable. It's kind in its own incomprehensible way. And this collision, though violent in scale, will be almost tender in rhythm. That's the paradox of it. Something so vast can also be so slow, so silent. Well, and scientists have already modeled it in exquisite detail. Using supercomputers, they've simulated the gravitational ballet frame by frame. The results are mesmerizing. First, the halos touch, then the disks warp, then great tidal tails form, long arcs of stars looping into intergalactic space. After a few billion years, friction within the dark matter halos slows the motion, bringing the two cores together. They merge, oscillate, and finally settle into one. The new galaxy will be oval, its spiral structure erased, its stars mixed beyond recognition. It will shine brighter, but move slower, its shape smoother and older. And, we sometimes call that end state Milkomeda, but maybe that's too neat a name for what it represents. It's not the end of one thing and the beginning of another. It's both. the Milky Way will survive inside Andromeda, and Andromeda inside the Milky Way. Every star, every cluster, every planet will find a new orbit in a new gravitational order. It's not loss, it's inheritance. The thought of this can stir something almost emotional, because it reminds us that nothing in the universe stands still. Everything, even the stars, moves toward transformation. We grow older, clocks tick, galaxies draw nearer. The cosmos itself is a living process, not a fixed map. And in that process, destruction and creation are the same act seen from two different points in time. Well, and this collision, this slow convergence, will have consequences far beyond the beauty of its sight. The merging of halos will redistribute dark matter across the local group, altering the gravitational balance that holds smaller galaxies in orbit. Many dwarfs now bound to the Milky Way will be absorbed. Others, caught in the tidal currents, may escape entirely, drifting into intergalactic space. The local gravitational architecture, the quiet scaffolding of our cosmic neighborhood, will be rewritten. And, well, scientists think the central black holes of both galaxies, Sagittarius A and Andromeda's much larger core, will eventually spiral toward each other. They'll orbit, tighten, and finally merge, releasing more energy in gravitational waves than all the stars of both galaxies emit in light. But that will happen in silence, in the deep future. The waves will ripple through space-time, carrying the memory of two galaxies becoming one. What's haunting is that the first signs of this collision are already measurable. The motion of Andromeda's stars, mapped by Gaia and the Hubble Space Telescope, shows the approach clearly. The halo distortions, the tidal stretching of satellite galaxies, all confirm the same truth. The future is in motion. The first act of the merger has already begun. It's not visible to our eyes yet, but it's there, written in the slow language of gravity. Well, and I sometimes think about what the night sky will look like billions of years from now during that dance. The Milky Way's familiar band will twist, warp, and fade, replaced by an enormous spiral rising across the heavens. Andromeda will swell until it dominates the sky, a disk larger than the moon, glowing softly. The constellations will dissolve. Orion, Cassiopeia, the Big Dipper, they'll all vanish, their stars pulled into new orbits. The sky we know is temporary, a phase between collisions. And, that realization humbles and comforts me, because it means that impermanence is not loss, it's participation. The universe changes because it's alive. The Milky Way and Andromeda are not static. They are stories still unfolding. Their meeting is not an accident. It's a continuation, written billions of years ago in the gravity that binds them. And as their halos merge, something else happens too. The local group, our small cosmic family, becomes more tightly bound. The smaller galaxies, Triangulum, Leo Phaxus, the Magellanic Clouds, will eventually join the merger, adding their stars to the growing system. The local group will condense into a single, immense galaxy surrounded by an expanding void. And as the rest of the universe accelerates outward, driven by dark energy, this lone giant will remain, a bright island in an ever-darkening sea. Well, and that's perhaps the most poetic part of it all. As the universe grows colder, emptier, and quieter, this merged galaxy will stand as a monument to what once was, a relic of light in a cosmos dominated by silence. Its stars will continue to burn, its black hole will hum softly at its heart, and its gravity will hold everything that remains. It's not an ending, it's endurance. And, The fact that we can predict this with such confidence, billions of years before it happens, is itself a kind of miracle. It shows how deeply we understand gravity, how much we can read from the faint motions of stars. But it also reminds us of humility, because even as we predict the grand future of galaxies, we still can't explain the full nature of what binds them. We can see gravity's effect, but not its source. We know dark matter shapes their halos, but we don't yet know what it is. We can map the future, but not the essence of what drives it. And maybe that's the real beauty here. The universe keeps us suspended between knowledge and wonder, between what we can measure and what we can only imagine. The Milky Way and Andromeda are not just two galaxies on a collision course. They're two questions approaching an answer. Well, and as we wait, as we measure, as we dream about what will come, one truth becomes clearer. The universe is not built on permanence, but on motion. Nothing stays still long enough to be defined. The galaxies, the stars, even space itself are all in transit. We grow older, clocks tick, galaxies converge, the cosmos breathes in cycles, and, well, as the Milky Way's fate entwines with Andromeda's, another thought begins to rise. If this merging is inevitable, if this transformation is universal, then maybe creation itself is not a singular event, but an ongoing process, one that continues even now, in every orbit, every tide, every flicker of light in the dark. And, that thought, quiet and profound, leads us forward. To what happens next, to what this cosmic merging means not just for galaxies, but for the universe itself, for the patterns it creates, the structures it reshapes, and the truths it forces us to rewrite. It's not just our galaxy that changed. When the Milky Way grew larger in the eyes of our instruments, when its weight tripled and its reach doubled, something deeper shifted beneath our understanding. Because if we were wrong about our own home, then, maybe we were wrong about everything else too. And that possibility is both exhilarating and, well, a little unsettling. James Webb began to turn its gaze outward, past Andromeda, past Triangulum, past the quiet shimmer of the local group. And what it saw, or rather what it revealed, was a pattern. Every galaxy it measured seemed, larger than before. Not just a few percent here or there, but consistently bigger, denser, heavier, and, if the Milky Way was twice its assumed size, so was Andromeda. So was Triangulum. The entire architecture of the nearby universe expanded before our eyes. Well, and the implications of that are vast. Galaxies, we now think, are not neat islands of light separated by emptiness. They are sprawling systems whose halos overlap, whose edges blur into each other's gravity. The space between them is smaller, the distances shorter. The boundaries of the cosmos itself begin to feel less like walls and more like tides. And, well, that means the rate of galactic encounters must rise. If everything is larger and closer, then everything interacts sooner. The quiet void we imagined is, in truth, full of motion, of halos brushing, of gravitational tides pulling unseen bridges of matter between neighbors. So what we once thought of as isolation is actually entanglement. And that changes the numbers. Cosmologists use galactic mass and separation to calculate merger rates, star formation histories, even the flow of dark matter through the cosmic web. But if all those galaxies are larger, if all their halos overlap, then the equations shift. The universe becomes a more connected place, denser, more social, more alive in its interactions. Well, And it's strange to realize that our view of the cosmos depended so much on our instrument's limits. We drew the edges where light faded, never questioning that light itself might be only part of the story. Now we see that galaxies don't end where their stars grow dim. They continue as diffuse halos of gas and dark matter extending far beyond. And that realization forces us to rewrite everything from the map of the local group to the models that describe how galaxies form. And, in a way, this feels like déjà vu. We used to think the solar system ended at Neptune. Then we found Pluto, and beyond it, the Kuiper Belt. And beyond that, a cloud of comets stretching nearly to interstellar space. Every time we think we've found a boundary, it turns out to be a horizon. The Milky Way is no different. The universe, it seems, has no real edges, only gradients. When Webb peered into Andromeda's faintest outskirts, it found streams of stars and dust stretching farther than anyone expected, overlapping with our galaxy's own halo. Those streams, those faint threads, mean the two galaxies are already intertwined. And if that's true for Andromeda, then it's likely true for others. For Triangulum, for the smaller dwarf galaxies orbiting nearby. Everything touches everything, however lightly. Well, this also means the local group itself may be more compact than we thought. The gravitational center of our small cluster of galaxies lies not between them, but within the shared halo of their merged influence. The space separating them isn't empty at all. It's a soft, dark sea of matter, unseen but present. And, if that's true here, in our neighborhood, then it's true everywhere. The cosmic web, the great network of filaments that connect clusters across billions of light years, might be denser than our models suggest. Each filament could contain more mass, each node more galaxies, each void smaller than we believed. That redefines what large-scale structure means. The universe might be less empty and more continuous, less like scattered islands, and more like an ocean with varying depths. But what does that mean for time, for evolution? If galaxies are larger and closer, they will merge, more often and faster. Cosmic time accelerates not because clocks tick quicker, but because events occur sooner. The grand cycles of formation and collapse compress slightly, enough to alter our understanding of how long galaxies live as distinct entities. The cosmos becomes, in a way, more dynamic. Its stillness a kind of illusion born of distance. Well, and that leads to another realization. If we have underestimated the sizes of galaxies, then we've underestimated their influence on one another. The gravitational dance that shapes the universe is far more intricate. The tugs and tides extend across greater spans, shaping not just local interactions, but the flow of entire regions. The boundaries between one galaxy's domain and another's are softer, more like waves meeting than borders colliding. And, this might also explain certain puzzles. For years, astronomers have noted that galaxies in clusters sometimes align their spins or shapes, as if responding to a shared rhythm. It seemed impossible across such distances. But now, with the recognition that halos extend far beyond the visible, that alignment makes sense. The invisible structures have always been in communication, pulling subtly on each other, synchronizing over cosmic timescales. And that's, well, poetic in a way. The universe, far from being silent and separate, hums with connection. Every galaxy feels its neighbor, however faintly. Every motion is part of a larger choreography. It's not chaos, it's complexity. It's not isolation, it's resonance. Well, And 2025 has already become a turning point for cosmology. The data from Webb, from Gaia, from deep field radio mapping, all converge on the same conclusion. Galaxies are not what we thought they were. They are not tidy spirals floating in emptiness. They are sprawling, breathing ecosystems of matter and energy, extending farther, weighing more, influencing everything around them. And if that's true, then our models of the universe's expansion, of its energy balance, of its future trajectory, all must adapt. And, well, that's where cosmologists now stand, between exhilaration and confusion. Because if every galaxy is bigger, then the total mass of the universe increases. But the expansion rate measured by supernovae and background radiation remains the same. So either the invisible energy driving that expansion, dark energy, is stronger than we thought, or the way we measure it needs rethinking. The smallest revision in scale ripples upward to the largest questions of existence. And I find something deeply human in that. Each time we refine our instruments, the universe responds by becoming more intricate. Knowledge doesn't shrink mystery, it multiplies it. We fix one boundary only to watch it dissolve into another. That's not failure, it's growth. Well, and perhaps the most humbling part is this. We might never know the full size of any galaxy, not even our own. Because galaxies fade gradually into the cosmic medium, their outer halos blending into the larger web. There's no clear edge to find. It's not that the universe hides from us, it's that it refuses to be reduced to a line. And, that idea of galaxies without borders, of matter flowing into matter, changes not just astronomy, but philosophy. It reminds us that separation is an illusion of perspective. The cosmos, like consciousness, is continuous. There are no true boundaries, only transitions. And as we look farther, measure deeper, model more precisely, one question begins to emerge beneath all others. If every galaxy is larger, if every connection runs deeper, then what happens to the structure that holds it all? What happens to the balance between gravity and expansion, between matter and the mysterious force that drives the universe apart? And, that's where we turn next, to the force we call dark energy, to the accelerating expansion that may, or may not, mean the universe's end. Because if galaxies are heavier, but space keeps stretching, then something, somewhere, must give. It begins, with a question we didn't expect to ask. If galaxies are bigger, denser, more massive than we thought, then where is all the ordinary matter that should go with that size? The universe, according to our equations, is supposed to be made mostly of invisible stuff, dark matter and dark energy. But even the small, visible portion, the part made of atoms, doesn't quite add up. About half of it, half of everything that should exist, is missing. That absence isn't just a number, it's a mystery. Well, and scientists call it the problem of the missing baryons. Baryons is the name for ordinary matter, the protons and neutrons that build stars, planets, people. The math says it should make up about 5% of the universe. But when astronomers count up all the visible hydrogen, helium, and heavier elements in galaxies and intergalactic gas, only half of that 5% is there. The rest has vanished. It's not dark matter, not exotic particles. It's the same stuff as you and me, just gone. And, James Webb is now peering into that absence. Its instruments, tuned to the faintest whispers of infrared light, are searching for the invisible half, matter so thin, so hot, so diffused, that no telescope before could see it. Because if galaxies are twice as large as we thought, their missing baryons must be hiding somewhere in those vast halos, or perhaps drifting in the space between them. It's not that they don't exist, it's that they exist in ways light can barely touch. There are a few possible explanations, none complete on their own. Some of the missing matter, scientists think, was blown out of galaxies long ago by violent events. Supernovae, quasars, winds from massive stars. These explosions, push gas out of galactic disks and into intergalactic space, where it cools so slowly that it disappears from view. The universe, in this picture, is littered with invisible smoke from ancient fires. Well, another theory says the missing baryons are still there, but in disguise, locked in enormous clouds of hot gas that fill the halos around galaxies. This gas can reach millions of degrees, hot enough to emit X-rays too faint to be detected until recently. Observations from the Chandra X-ray Observatory and now Webb's near-infrared spectrographs are beginning to trace their outlines. And, well, what they show is both elegant and eerie. Halos of glowing plasma stretching hundreds of thousands of light years, forming a web of ghostly bridges between galaxies. And, the third possibility is even stranger, that the missing matter lies in the space between galaxies, in filaments of gas connecting clusters together like strands of silk. This intergalactic medium, sometimes called the warm-hot baryonic medium, might be where most of the universe's normal matter actually lives. It's not in stars, not in planets, not even in galaxies, but suspended in vast invisible rivers that carry material from one galactic system to another. The cosmos, then, is not an empty void, but a dynamic ocean, flowing, exchanging, breathing. And the deeper Webb looks, the more that ocean comes into view. Its infrared eyes detect the faint emission lines of oxygen and hydrogen scattered across cosmic filaments, hints of a hidden network connecting everything. That's what's beautiful about this moment in 2025. We're finally beginning to see the unseen half of our universe. Not just the dark matter, but the missing ordinary matter too. Well, and the irony is that the missing baryons were never truly gone. They were hiding in the spaces between our questions, in the gaps between what our telescopes could see and what we believed was real. It's not that the universe was incomplete, it's that our sight was. Science didn't change the cosmos, it changed our position within it. And, that realization reframes everything. If half of the universe's ordinary matter lies outside galaxies, then the boundaries between galaxies and intergalactic space are not clear-cut. They blur. The Milky Way's halo might merge seamlessly into the next, forming an unbroken continuum of gas and gravity. It's not this galaxy or that one. It's one grand system, a single fabric woven of light and shadow. And that fabric matters, because the missing baryons are the raw material of creation, the atoms that form new stars, the elements that build new worlds. Finding them means understanding how galaxies breathe, how they take in matter, how they lose it, how they recycle it over cosmic time. That's not just astronomy. It's genealogy. It's tracing the ancestry of everything we know. Well, some scientists even think the missing matter holds the key to cosmic balance. If too much baryonic matter escapes galaxies, they fade. If too little, they collapse. The missing half may be part of a natural rhythm, a breathing pattern that regulates the life of the universe. Gas flows in, forms stars, is blown out, cools, and drifts back again. It's not loss. its circulation. And, this too has consequences for how we understand ourselves. Every atom in our bodies was once part of this cycle. Some may have been flung out by an ancient supernova, cooled for billions of years in intergalactic space, and then, reabsorbed into a new galaxy that birthed a new star, a new planet, a new life. The missing baryons aren't missing from us. They are us, just waiting for their next transformation. The search for them also reshapes our sense of cosmic scale. It reminds us that visibility is not the same as existence, that what glows brightest is not necessarily what matters most. The invisible half of the universe does most of the work, holding galaxies together, fueling their growth, balancing their heat. The visible half merely traces its surface, like frost outlining an unseen window pane. Well, and as James Webb continues to map this hidden matter, it's beginning to rewrite the great equations that describe the universe. The ratio of baryons to dark matter, once thought fixed, may shift. The interplay between gravity and pressure, between cooling and heating, may need to be redefined. And, that could ripple outward, to models of star formation, of galactic evolution, even to how we calculate the age and density of the cosmos itself. And, well, that's the quiet genius of this era of astronomy. Every discovery about what's missing brings us closer to what's true. The universe isn't getting simpler as we learn more. It's getting deeper. Each mystery we solve reveals another, finer layer beneath it. The missing baryons aren't a flaw in our understanding. They're a reminder that understanding itself is always partial. So when we talk about what's missing, maybe we're really talking about what's waiting, to be seen, to be imagined, to be known. And, maybe that's what science is at its core, not the act of finding, but of continuing to look. Well, and as we trace these invisible filaments of gas and matter stretching between galaxies, another thought begins to take shape. If half the ordinary matter of the universe hides in these threads, what of the other half? The invisible forces that push galaxies apart. If gravity pulls and matter binds, then what is it that drives expansion, that accelerates it, that seems to fight against the very fabric holding everything together? And, that question leads us, almost inevitably, toward the next horizon, to dark energy itself, to the force that balances and defies all others, the one that may decide the ultimate fate of everything that exists. It's, not easy to talk about dark energy without, well, feeling a little small. Because, it's not something we can see or touch. It's not starlight or gas or even dark matter. It's something else. Something that fills the void between galaxies. Something that pushes instead of pulls. And, if galaxies are heavier and larger than we thought, if their gravity is stronger, then dark energy must be even stronger still to overcome that pull. Well, that's where the paradox begins. The new measurements, the ones from James Webb and Gaia, show that galaxies everywhere contain more mass than we expected. Their halos are denser, their reach farther. So when we plug those numbers into the equations of cosmology, something doesn't add up. The universe should be slowing down more than it is, but it's not. It's still expanding, still accelerating, as if some hidden hand keeps pressing outward. That imbalance is what we call dark energy. And, dark energy makes up almost 70% of the total energy in the universe. Not stars, not matter, not anything we can see. Just this invisible pressure woven into the fabric of space itself. It's not just out there, it's in here, in the very geometry of reality. Einstein's equations predicted it could exist, though he called it the cosmological constant and later thought it a mistake. But maybe, it wasn't a mistake at all. Maybe it was the first whisper of what we now know fills most of the cosmos. Still, the discovery that galaxies weigh more means that our balance sheet of the universe is wrong. If gravity is stronger than expected, then to keep the same observed rate of expansion, dark energy must also be stronger. That means the cosmological constant, the lambda in our equations, might need to grow. But, constants aren't supposed to grow. Either our understanding of dark energy is incomplete, or the entire model we use, the lambda CDM model, needs rethinking. Well, and that model has been our cosmic map for decades. It explains nearly everything: the birth of galaxies, the glow of the cosmic microwave background, the large-scale structure of the universe. But now, under Webb's sharper gaze, its edges start to fray. The more precisely we measure, the more cracks appear. Galaxies too heavy, expansion too fast, early structures too mature. It's not just a few data points out of place. It's a pattern, a quiet hint that something deeper lies beneath. And, this makes scientists nervous in the best possible way. Because, when a theory begins to fail, discovery begins to grow. Some suggest that dark energy isn't constant at all, that it changes over time, like a fading field or a tide that waxes and wanes. Others propose that gravity itself might be different on cosmic scales, not as Newton or Einstein described, but warped by some new physics. The universe could be more flexible, more alive in its own expansion than we've dared to imagine. But what's fascinating, what keeps cosmologists awake at night, is that every new observation forces us to redraw the boundary between matter and mystery. When galaxies grow heavier, dark energy must stretch harder to balance them. It's a cosmic tug-of-war where both sides keep changing their strength. And, well, maybe that's why the universe feels so delicately tuned, because it's not balanced by design, but by constant negotiation. Well, if dark energy is real, it acts everywhere, even here, even now. Every cubic meter of space carries a faint pressure, a kind of negative gravity that pushes everything apart. It's not much, just enough that over billions of years it adds up. Galaxies drift, clusters scatter, voids widen. We grow older, clocks tick, and the cosmos itself expands around us. That gentle stretching of space is the quiet background music to everything that happens. And, yet we still don't know what it is. We can name it, describe its effects, even measure its strength, but not its nature. Some think it's a property of space itself, an energy that can never be removed. Others believe it's the sign of an unseen field that fills the cosmos, similar to the Higgs, but infinitely subtler. And there are those who wonder if it's not energy at all, but a sign that our understanding of space-time geometry is flawed. It's not the universe that's accelerating. It's our equations that are incomplete. And that last idea is haunting, because it suggests that dark energy might not be a thing, but a misunderstanding, a symptom of deeper physics we can't yet see. That wouldn't make the discovery less profound. It would make it more. Every time we've thought we understood gravity, the universe has whispered, "Look closer." And every time we've looked closer, something entirely new has emerged. Well, and as of 2025, that whisper has become louder. Webb's data on distant galaxies shows them forming faster, shining brighter, clustering more tightly than the standard model predicts. If dark energy's strength has remained constant, this shouldn't be possible. So either dark energy has changed, or something else has been guiding the cosmic expansion, a missing piece of the puzzle we haven't even named yet. And, that realization is both terrifying and beautiful. It means that the universe is not done surprising us, that what we call laws may be more like habits, consistent only until the next discovery bends them. Science isn't about certainties. It's about the courage to keep questioning even when the answers dissolve. And when I think of dark energy, I imagine it less as a force and more as a rhythm, a slow heartbeat within space-time, expanding and breathing with every moment. It's not out there beyond the galaxies. It's everywhere, between atoms, between thoughts, between what we know and what we still reach toward. Well, and if that's true, then maybe our expanding universe isn't running away from itself. It's unfolding into itself. The distance between galaxies isn't emptiness growing. It's creation continuing. It's not destruction. It's continuation. The cosmos isn't thinning out. It's deepening. And, that perspective changes the meaning of everything we measure. The growth of galaxies, the pull of gravity, the stretch of light across time, all of it becomes part of one ongoing story. A universe balancing its weight and its flight, its pull and its push, its darkness and its radiance. And in that balance lies a question we still can't answer. What happens next? If dark energy keeps accelerating expansion, galaxies will drift so far apart that even light won't cross the gaps. Stars will burn out, matter will decay, and the universe will fade into silence. But, if dark energy weakens or reverses, gravity might reclaim dominance, pulling everything back together into a single, fiery end. The fate of everything depends on what dark energy truly is, and we still don't know whether it will endure or fade, strengthen or surrender. Well, and maybe that's what makes this era of discovery so human. We stand at the edge of knowledge, holding tools built from our own curiosity, staring into a mystery that seems both infinite and intimate. The universe expands, and so does our understanding, and the two movements mirror each other like breath and heartbeat. And, perhaps that's the quiet truth beneath all of this, that the cosmos is not something we merely observe. It's something we participate in. Its expansion is our expansion. Its questions are our questions. Its dark energy, unseen and untouchable, might just be the universe reminding us that the greatest forces are the ones we can't yet define. And as we trace that invisible push through the galaxies, measuring its strength, mapping its reach, we begin to see the next horizon rising. The question not of what the universe is made of, but of what it means for us to exist within it. Because the deeper we look into darkness, the more it reflects something familiar, something fragile, something almost human. And, well, that's where the next chapter must begin. It's, strange, isn't it, to realize that the more we learn about the galaxy, the more we end up learning about ourselves. The discovery that the Milky Way is twice as wide, 3 times as heavy, and immeasurably more intricate than we ever thought. It doesn't just shift the numbers, it shifts the meaning. Because, if the galaxy has no real edge, if it simply fades into the dark, then where exactly do we end, and where does it begin? Well, and maybe that's the quiet beauty of 2025. We're starting to see that the cosmos is not divided between observer and observed. It's not out there. It's in here, in every atom that built us, in every photon that crosses our eyes. The same forces that swirl stars around the galactic core move the electrons in our blood. That's not metaphor. It's physics. And yet, it feels like poetry. And, what James Webb and Gaia have shown us is that our home galaxy isn't some distant island of light. It's a living ocean. Its stars, dust, and dark matter move like currents, looping endlessly in and out of view. The halo that surrounds it isn't a border, but a breath, exhaling into the cosmic sea. And we, Earth, the Sun, every atom of our existence, are part of that breath. Brian Cox once said that to look up at the stars is to look back in time, but, well, he might have understated it. We don't just look back in time, we belong to it. Every element in our bodies was forged in the collapse of a star, scattered into space, and reassembled billions of years later into flesh and thought. The Milky Way, in that sense, is not just our address, it's our ancestry. And, well, that ancestry is older and broader than we imagined. When scientists found that our galaxy stretches nearly 200,000 light-years, they realized it overlaps with the halos of others. The borders blur. The edges dissolve. It's not Milky Way here, and Andromeda there. It's a single continuum, an interwoven sheet of gravity and time. That means, even now, as we speak, the atoms in our bodies are drifting in a slow, gravitational tide toward another galaxy. The future collision isn't something that will happen. It's something that's already begun. Well, and it's not a violent thing. Not really. When Andromeda and the Milky Way finally meet billions of years from now, their stars will barely collide. Most of the galaxies are empty space, after all. What happens instead is something gentler, a slow merging, a weaving of two spirals into one vast new system. Not destruction, but transformation. It's not an end, it's an evolution. And, if that's true for galaxies, maybe it's true for us too. We grow older, clocks tick, and yet the things we call endings often turn out to be beginnings in disguise. The merging of two galaxies is not death, but rebirth, not chaos, but choreography. And we are lucky enough to exist at a moment when we can see that dance beginning, quietly, invisibly, in the halos of dark matter that have already intertwined. And when we look at those halos, those invisible cocoons of gravity that hold galaxies together, it's hard not to think of how much we owe to things we can't see. The invisible keeps everything from falling apart. It's not just dark matter holding stars in orbit. It's the unseen kindnesses, the unspoken thoughts, the invisible ties that hold our human lives together too. The structure of the cosmos and the structure of consciousness are, well, not so different. And, well, maybe that's what the new science is trying to tell us. That we are not smaller because the galaxy is larger. We are not lost because the universe is vast. We are participants in it, threads in its fabric, witnesses and expressions of its unfolding story. The more the cosmos expands, the more we discover our place within it. It's not that the Milky Way has grown, it's that our understanding has. Well, and understanding always changes the shape of what is known. The maps we draw are not just for navigation, they're mirrors. When we chart the spiral arms, when we trace the streams of stars wrapping around our galaxy, we are, in a way, mapping ourselves. Every coordinate, every distance, every velocity line is a reflection of our need to know where we stand in all this immensity. And, that need is ancient. Long before James Webb, long before Gaia, long before even Galileo, People looked up at the Milky Way and wondered what it was. A river? A road? The breath of gods? The souls of the dead? Now we know it's none of those things, and yet it's also all of them. Because the truth is not smaller than the myth, it's greater. The river is made of stars, and we are part of its flow. The road leads everywhere, including home. So when we say the Milky Way is 200,000 light-years wide, what we really mean is that the home we belong to is larger than language. Its scale defies imagination, but its presence is intimate. It hums in every cell, in every heartbeat. It's not a distant abstraction. It's the field of being itself. We don't live in the galaxy. We are the galaxy for a fleeting moment, aware of itself. And, perhaps that's the most profound discovery of all. The recognition that knowledge does not make us insignificant. It makes us connected. To know more about the cosmos is not to feel smaller, but to feel larger in the way understanding always enlarges the soul. It's not humility that science teaches, it's belonging. Well, and that belonging carries responsibility too. If we are part of this vast breathing structure, then so is everything we do. Our actions echo across scales, from the microscopic to the cosmic. The same physics that binds galaxies also governs the delicate balance of life on Earth. The same entropy that cools the stars will one day cool our sun. Knowing that doesn't diminish the beauty. It deepens it. And, maybe that's the quiet message hidden in all these discoveries. That science and wonder are not opposites. They are partners in the same conversation. Every equation is a kind of prayer. Every telescope, a kind of confession. That we want to see more, understand more, become more. The Milky Way doesn't just surround us, it invites us. And so we look up, not to escape, but to return. To the truth that the cosmos is not elsewhere, but here, not later, but now. That we are starlight, thinking of itself. That every new discovery, every measurement, every recalculation is not an act of correction, but of communion. Well, and as the light from distant stars continues to fall upon us, light older than our species, older even than the Earth, we are reminded that to study the universe is to study the mirror of our own becoming. It's not knowledge that ends, it's knowledge that begins again, always deeper, always wider, always brighter. And, from that widening comes the next question, one that reaches beyond even galaxies, beyond even light itself. What if the universe is not just expanding in space, but in meaning? What if, every new discovery is the cosmos learning to know itself through us? What if consciousness and creation are two sides of the same unfolding story? And, well, perhaps that's where we must go next, to the question of awareness itself, to the mystery not of what the universe is, but why it dreams. The discovery that the Milky Way is not what we once believed. It's not a neat, bounded disk of light, but an immense, breathing structure of dust, gravity, and time, changes more than astronomy. It changes us. It reminds us that knowledge does not shrink the universe. It stretches imagination until wonder becomes as wide as reality itself. The truth revealed by James Webb and Gaia is not the end of mystery. It's the renewal of it. Every time we think we have reached the edges, the horizon moves, and the cosmos grows deeper. And, maybe that's the quiet lesson hidden beneath every calculation and image. That what we call discovery is really recognition, a remembering that we are not apart from the universe, but an expression of it. The Milky Way's doubled size does not make us smaller. it makes our belonging more profound. We are woven into a system 200,000 light-years across, held by forces invisible yet unbreakable, orbiting together through darkness and time. Well, when scientists rewrite the textbooks in 2025, it won't just be numbers that change, it will be perspective. Because to realize that the galaxy is twice as large is to realize that our capacity for understanding is also twice as large. The cosmos doesn't diminish mystery, it multiplies it. Each new discovery lights not an answer, but another path forward. And, that's why science matters. Not because it closes questions, but because it keeps asking better ones. The Webb telescope hasn't reduced awe, it has deepened it. It has shown that even in the most familiar of places, our own galactic home, there are still unseen regions waiting to be revealed. It's not that the unknown is far away. It's right here, shining faintly behind the veil of dust, waiting for our eyes to adjust. Maybe that's what Brian Cox meant when he said that science doesn't destroy mystery. It expands it. Because, well, every time we look closer, we find that reality is not smaller than imagination. It's bigger, stranger, more luminous. The Milky Way isn't a backdrop. It's a story still being written, and somehow, impossibly, we are part of its script. And, well, that's the miracle of it all, that out of the quiet dark between stars, a small species on a small world built instruments of glass and light to see beyond its limits. We are the universe looking back at itself, trying to remember where it began and where it's going next. So, the next time you look up and see that pale ribbon stretching across the night, remember, it's not just starlight from distant suns. It's a map of our origin, our present, and our future. The more we learn, the more we belong. The more we see, the more we are seen. And, as the telescopes keep searching and the galaxies keep unfolding, we'll continue this endless dialogue between wonder and understanding. Because in the end, the cosmos is not simply out there. It's in here, alive, expanding, waiting for us to notice.